Thank you for attending our session. Welcome. We are Uptake, and we wanted to talk a little bit about what we're doing in predictive maintenance today. So first of all, I'd like to announce that we've been a Geotab partner for some time, but we just recently launched on the marketplace, which is very exciting for us. So who are we? We believe that the world should always work. Machines should not break, and maintenance should be something that could either be scheduled or planned. And in fact, the data and the tools exist to be able to do this today. And this is something that we are already doing now with industrial leaders around the world. And in fact, we want to empower you to be a part of that reality as well. And in fact, the Geotabs that you already have installed in your vehicles can enable you to do that now with our help. Here are just a few of the industrial leaders globally that are currently using Uptake. And now I would like to introduce you to Braden, who is going to talk a little bit more about what we are doing within the fleet space.
Thank you, Kate. So Kate mentioned that we're delivering these insights out of the Geotab data that's available today. The key benefit is we have all of the data that we need to make these intelligent decisions. We just need tools and the ability to analyze that data and drive outcomes into our business. And Uptake is focused on delivering two distinct types of outcomes. Number one is providing advance notice. How do we allow the users to be proactive about maintenance events? How do we give them lead time to be able to plan this work and make sure that they have the right shop, the right technician, and the right parts to decrease the downtime as much as possible. The other value is finding the signal in all the noise. I mentioned all of the data is there, but if you turn on the spigot, it's completely overwhelming. Fault codes, signal data, work order data. You spend a lot of time just trying to get your arms around it and figure out what to do. So finding the signal in all the noise using tools like AI and machine learning so you are better informed when that truck is in front of you ready to be maintained. Our industrial AI platform leverages a lot of data points and takes in data inputs from across your business. Key data inputs come from the telematics device. So Geotab gives us access to fault codes. We look at the raw sensor data below those fault codes. We also look at failure data from historical maintenance, as well as SME input. And we do a lot of things with this data once it comes into our platform. For the fault codes, we look at smart grouping of these fault codes, density and persistence analysis to determine what those fault codes actually mean. On the raw sensor data, we're doing things like supervised and unsupervised learning, understanding the physics behind these failure modes and what drives economic outcomes for our customers. There's a lot of information that lies within the failure data. What should I target? What is costing me the most? What is causing the most downtime within my fleet? And where do I focus my attention? We also look at things like benchmarking, mean time to failure, survival analysis. These are all just inputs to this. How do I maintain this truck today based on its condition? And then certainly the folks who maintain these assets know them better than anybody. The folks that operate these assets know them better than we ever will. So determining the SME input is a key piece of driving value out of all this data. I'm going to quickly hand it over to Brendan from PepsiCo, give you a little bit of information about his fleet and also why predictive failure analysis is important to him.
Thanks, Braden. So if you guys are not familiar, I'm sure you've seen enough of us, but the FritoLay and PepsiCo fleet works out to be about 70,000 assets all told. So we have lots of opportunity in a way of our scope, but we're also a pretty efficient fleet. So we've been going back to the well trying to figure out, every year we go back to telematics and ask what more can the telematics give me, right? Just continue to go back into that productivity pipeline. And really we're starting to split hairs in reliability now. So how do I get that last 1 or 2% of reliability? And really using predictive maintenance is going to be the place that we're going to do that. So we're looking at a number of options in predictive maintenance, but one of the big ones we're excited about this year is that we're partnering with Uptake on a pilot project focused on the CNG tractors specifically. So on the FritoLay side, we have about 1,500 over-the-road Class 8 tractors. almost half of which are compressed natural gas equipment at this point. So we have a mix of some of the older 9 liters, but vast majority are the 12-liter Cummins CNG platform, and they work very, very well for us in many ways. But there are some unique challenges with CNG when it comes to reliability, especially because we were an early adopter in the technology. So we're out ahead of the life cycle of those vehicles in terms of the industry. So we're learning things as we go, and trying to find the opportunity to offset some of these major failures we're starting to see. How can we go back in time and look at all this work order data I have, and look at all this telematics data I have, and go address a very specific problem that I have in the business, which is that at a high level, in the heads, right, we're getting the valves actually recess. And then you'll end up with excess fuel in the exhaust system, which melts the catalyst. So it turns a $10,000 problem potentially into a $30,000 or $40,000 problem very quickly, and we need to be able to catch it in the middle. However, it's very expensive to pull the heads off, so I can't just go campaign every vehicle all at once. So I have to be smart about when we want to do that work, and that's what we're focused on for this pilot. I guess I talked out ahead of my slides. I'm sorry, Braden. No, that's good. But yeah, so this is in terms of why predictive maintenance at Pepsi. I kind of covered that, but really, we have all the pieces, right? I have all the resources that we needed, other than some horsepower, which Uptake is helping us out with, to go do this work and to go really forge a path towards this solution for us. So this is where this is our focus on our roadmap for Pepsi right now in terms of how I'm going to go drive reliability in the business is focused on telematics and predictive maintenance.
Thanks, Brendan. So the Pepsi team had a presentation earlier talking about the results they've seen within the electrical group, right? 12% reduction in roadside failures, improvement in availability, and ultimately also an improvement in the diagnostic time from technicians. So they've seen the proven results of predictive maintenance. Now, how do we scale that across other targeted areas within their business? And that's what I want to talk about here over the next couple minutes. So looking at specific examples of how we are using the AI and machine learning tools to drive outcomes that help this team better maintain these specific assets. Now, the issue that Brendan mentioned, the valve recession within the CNG cylinder heads, is the target of the next couple months here. We are out to solve this problem. As with anything that Uptake does, and as anything with predictive maintenance, data is the key, right? So what data sources do we have available to try to solve this challenge? Now, what we're looking at here is one of our fault-based modeling techniques. Unfortunately, today, there's not a lot of signals available that lead us to failures around these CNG engines. We're going to work with PepsiCo and Geotab and other partners to try to enable those signals, but using what we have today, we can generate insights. So just to kind of make you familiar with the chart here, you're looking at 2 different fault codes that have occurred over a period of time. The yellow bars that are vertical there are work orders that occurred within the PepsiCo system. And then the blue shaded areas are the Uptake insight, when that insight would have been active. You also see some red dots here on the far right-hand side. That's indicative of a red stop lamp being on with that fault code. So check engine light within the cab has been on when that red fault code fires. So ultimately, I talked about the persistence analysis, the density analysis, the grouping of these particular fault codes. But ultimately, the insight here would have been generated about 60 days before the check engine light came on within this truck. So what does that mean to Pepsi? That's advanced notice. That's avoiding that degradation that compounds the longer this goes, and ultimately trying to avoid those $20,000 replacements of these cylinder heads. Another example with a few more fault codes incorporated here. You can see some random examples where a red stop lamp just shows up on cylinder number 3. Is that real or is that noise? And those are the tools that we are using to try to determine the action versus what's just a random occurrence of a particular fault code. Another example, again, 60 days prior to the red stop lamp coming on, the Uptake insight started being generated. You see a work order that was created that turned off the Uptake insight for a couple weeks' time. But ultimately, that insight came back. This root cause was not fixed. This is continuous failure that's happening across this. And certainly at the end here, we want to take this in and take a look at it and action it if possible. So those are 2 key examples for the CNG assets, again, leveraging the fault-based analytics. But the other big area that we're diving into is the signal-based analytics. So Not specific to the CNG assets here, but just wanted to give some examples of how we're looking at these failures. An engine overheating model that takes a look at a couple different temperature sensors, the primary indicator being the coolant temperature. And this is a period of about 3 months' time, and we want to see the trend of that coolant temperature over those 3 months. We don't want to just send an alert every time it goes over 205 or 210. That could be it's going up a hill. It could be it's 100 degrees in Arizona. We want to understand the pattern that is happening that has led to failure in the past. We train all these models against historical failure data to understand what patterns actually cause on-road breakdowns. And here you can see about 30 days prior to a work order being created, our insight started being generated when that coolant temperature spiked. Now, 30 days later, the driver reported a coolant leak, brought it in for a work order. Truck went back out on the road, and a couple weeks later, that insight started being generated again. The same pattern of increased coolant temperatures was happening. So this is a potential issue where the root cause, again, may not have been fixed right, or there's something else happening within this asset. Now, one of the biggest areas that we're focused on, and I know many of you are focused on as well, is the aftertreatment system. Big cause of downtime, big cause of cost within our partners, and an area that we can get really specific on failure modes. We've deployed about 10 different failure-based models within the aftertreatment system. Anything from a DPF failure to a DOC face plug, DEF use, and this is an example of our EGR cooler failure model. And here we're looking at, again, a number of different signals go into this modeling technique, but namely we're looking at the correlation between the temperature within the EGR and also the temperature within the engine and the coolant itself to see how those correlate and to watch for patterns of increased EGR temperature that are indicative of those coolers failing. So this is early detection of this potential failure that not only has an impact on this specific component, but also, again, that cascading and catastrophic impact if it continues. All in all, within our platform today, we have over 40 of those signal-based models deployed. They cover 6 major systems within a truck. And we look at anything from diesel to CNG to gasoline assets and deploy the same type of modeling techniques across assets of all types and all sizes. And for our customers, we're delivering about $2,400 in annual value creation per vehicle. And this is by creating that advanced notice. This is by decreasing the diagnostic time and improving efficiencies within the shop, and ultimately fixing the problems before they cause that engine to be lost. Make the easy and cheaper repair now, as opposed to the on-road breakdown later. We've seen these insights really start to benefit the entire operations for our customers. Really, the ability to plan downtime and avoid those downstream failures is key. That's what drives cost savings. That's what drives efficiency savings. That also carries over to number 2, streamlining those shop operations. Not only improving diagnostic time, but ensuring you have the part and the technician and the skill set and the bay available. Maybe directing these repairs to your shop instead of an outsourced shop, or the right outsourced shop. So completely streamlining and creating efficiencies within that part of the operation. Service and driver interruptions are absolutely critical to all our business, especially in the trucking space, over the road space. Drivers are hard enough to hire and retain. We want to put them in vehicles that are reliable and don't have that unplanned downtime, which may start to drive them elsewhere. Improving the repair accuracy by targeting specific failure modes. We saw an example earlier about the engine overheating model that coolant leak was reported, but the engine continued to rise in temperature after that repair was made. So how do we point the technicians to the right failure mode so they are looking for the right issues and fixing the right thing the first time? And ultimately, the more reliable and well-maintained our fleet is also impacts the efficiency and fuel efficiency of these assets, making sure we have the most reliable and efficient vehicles on the road. So what makes Uptake different? There's plenty of people that are looking at signal data, at fault data, at work order data, and trying to determine this predictive maintenance equation. Uptake is one, different because we're looking at that underlying signal data. That's where the Geotab partnership really comes in and benefits us all. We not only look at that fault data, but the underlying signal data across 100 or so different channels to determine the failures that are occurring within this asset. We've got proven results, not only in the commercial vehicle space, but we've been doing this for years on locomotives, on wind turbines, and construction equipment, mining equipment, et cetera. We've seen this approach work across heavy industrial assets, and we've seen it work across commercial fleet assets. We've also invested about $300 million into our platform. This type of technology, it takes a lot of effort, a lot of money to get off the ground, and this is our sole focus, industrial AI. And we have the ability to generate insights very quickly. Our ability to deploy and train these models on over 1 billion hours of data allows us to hook up to a new customer and generate predictive insights within a day. So I'm going to invite Kate back up here and talk a little bit about our offer.
Thank you, Braden. So now that you've all had an opportunity to hear a little bit more about what we do and the value that we bring, I wanted to talk to you about a promotion that we're running specific for the Geotab Connect show. So right now we're offering a free 2-month live trial on our platform, and it's very simple. All you need to do is provide us access to your data within the next 2 weeks, and we will go ahead and get you set up on our platform, get you a login, do a demo for you, and you'll have the platform to be able to use for those 2 months for free. Additionally, we can turn that around very quickly. Just to give you an example, this morning we had somebody who went ahead and signed up for this program. They gave us their data this morning, and by about an hour ago, we actually had their data up and running on our platform, and we already generated about 80 insights for the last 4 months of their vehicles. So they already have their first actionable insights to be able to check into. Come check us out at the booth. Talk to us about how you can get started with this as well. And for you resellers out there, I see there are a few. We also have a partnership program, which could be very interesting as well, to add an additional product to your portfolio. And we do both referral and resell options there. So please come to our booth and chat with us about it, and we hope to see you there. Any questions?
Any? All right.
Please. You want to come up stage?
Does it work with OBD2, small mid-sized trucks as well?
Yeah, absolutely. So the technology will carry over based on different vehicle classes and vehicle types. I think the one designation that we always look for is what data is available. So out of those 40 signal-based models, we may be able to enable a handful, maybe 10 or so, based on the signals that may be generated by those light-duty vehicles. So it works with the OBD2 protocol. The data would come in the same way through the Geotab device into our platform, and we determine which models that we can enable based on the data that's available from that asset type.
Great. Any other questions? No? All right. Thank you to Uptake for your presentation. As I said, please visit their booth if you have questions later on, and enjoy Connect 2020 for the rest of the afternoon.